I'm James Hague, Knowledge Exchange Manager with AHDB Dairy, and I've come to Harper Adams to speak to Professor Liam Sinclair about why ammonia is an issue and how dairy farmers can play a role in its reduction. Liam, there's a lot of recent press and public interest in ammonia release from dairy farms. Is this really the case, and what is the problem?
Well, the problem relates to the air quality and what's called the fine particulate material that you can get within the air, particularly material that's less than 2.5 micrometers, so PM 2.5. So a normal hair on a human head is about 50 to 70 micrometers, so 2.5 is really very small. And what that does is it causes sort of lung irritation and has been associated with reducing life expectancies. So reducing that fine particulate material has become really quite important, and it's part of the reason why we get low emission zones within some cities, and it's why diesel cars have generally gone out of favour. But one of the major contributors towards these fine particulate material is ammonia, and agriculture contributes about 88% of the ammonia release within the UK.
And why the focus particularly on dairy and beef farms?
Well, within agriculture, dairy and beef farms combined make up almost 50% of the ammonia release. So there's been a lot of focus in doing that. Pig and poultry, there was legislation that came in just over 20 years ago, and they have literally cleaned their act up and reduced the output. So now the major focus is on beef and dairy, particularly dairy farms who contribute about 27% of ammonia release. And that ammonia release can come from a variety of reasons. It can come because of the diet and overfeeding protein, but also how we move and store manure. And then the third main area is how we apply that manure and artificial fertiliser onto the ground to avoid this ammonia release.
And AHDB has been funding Harper Adams for some research to conduct and trying to help farmers. And what are the main findings of that research?
Well, what we've been focusing here at Harper Adams is to feed low protein diets. So if there's less protein in the diet, then there will be less urea excreted, because cows don't excrete ammonia. What they excrete is urea. So for a typical cow, maybe giving about 32 kilograms of milk a day, she's eating about 4 kilograms of protein, but there's about 1 kilogram of protein coming out in the milk. So that's about 25% efficient. So the other 75% is then going to go and potentially contribute towards nitrates and NVZs and also ammonia. So the fecal material will be about 30% and about 45% will be coming out in the urine and urea. So what we've been focusing on is to see if we can reduce the protein level, and a typical UK farm would be about 17 to 17.5% protein and get it down to about 15% protein. But we've also been looking at another element in there, and that's to look at forage legumes. Now, forage legumes are higher in protein than grass silage, and their advantage is that you don't need to purchase as much additional feed in to balance the ration. So we've been focusing on red clover and lucerne to be able to get these low protein diets. Now, the difficulty with these forage legumes is that they tend to be the wrong type of protein, what we call too much rumen degradable protein. And really what we need to be focusing on is not just the crude protein amount, which is what farmers are familiar with, but actually what we call the metabolisable protein. Now, the analogy I would give there is we formulate rations for cows based on metabolisable energy, but feeds have a gross energy, the total energy content. So 1 kilogram of wheat straw and 1 kilogram of wheat grains have got approximately the same amount of gross energy, but we know that when we feed cows, that the cow gets a lot more energy from the wheat grains, and the ME content is more than twice the level of the straw. And the same comes with protein as well. Crude protein doesn't really tell us whether we have the right type of protein. We should be focusing for metabolisable protein. So what we've been doing is getting the protein level down from 17.5 to about 15%, but maintaining the same metabolisable protein, and also looking at the amino acid content of that protein, because that becomes more important because cows actually metabolize amino acids, which are the building blocks of protein, rather than protein in its entirety. And what we were able to show is that we can get levels down from 17.5 to 15%, we can maintain intake, maintain performance, but we can get the nitrogen use efficiency up from that 25% up to about 35%. And the net effect is that that results in about 60 to 70 grams less of urea being excreted in the urine each day. And to put that in perhaps a more understandable currency, that's about 50 kilograms of nitrogen per hectare less coming out from the cows that's not going onto the land and contributing towards ammonia release. So that's a big saving. In terms of farm costs, it's also slightly cheaper because you're feeding less protein, which is more expensive, but you need to feed perhaps a higher quality protein to make sure that you supply that metabolizable protein. So there will be a slight saving in cost, but not a massive saving. But you can maintain the performance and reduce the nitrogen and potentially ammonia release from dairy cows.